In this video, we're going to continue our discussion of power series functions. The question here is to express the function f of x is equal to log x as a power series in powers of x minus e, and also find the radius and interval of convergence. We're given this hint that a function log of 1 plus u can be represented by the power series summation n equals 0 to infinity, negative 1 to the power of n, times u to the power of n plus 1 divided by n plus 1. And the interval of convergence is absolute value of u less than 1. That means u is less than 1, larger than negative 1. This means that for these values of u, the function log of 1 plus u can be represented by this power series. All right, let's start by writing log x as log of e plus x minus e. Now we can factor out an e inside the bracket, so we get ln of e times 1 plus x minus e divided by e. Now let's apply the log rule for multiplication to split up the logs. So we get log of x is equal to log of e plus log of 1 plus x minus e divided by e. So the rule we're applying is log of xy, log of a product, is going to be the sum of the logs. So log x plus log y. This is just a property of logs. All right. Now let's let u be equal to x minus e divided by e. And now we can apply the hint. So we're letting this part be u. So log x is equal to log of e, which is equal to 1, plus, now let's apply the power series representation for log of 1 plus u. So that's going to be summation n equals 0 to infinity minus 1 to the power of n times u to the power of n plus 1, but u is equal to x minus e divided by e. So x minus e, we put that inside the bracket for u, that's divided by e to the power of n plus 1 divided by n plus 1. Now, very important that we understand this process. We're applying this hint. Log of 1 plus u is equal to summation n equals 0 to infinity, negative 1 to the power of n times u to the power of n plus 1 divided by n plus 1. We're substituting u is equal to x minus e divided by e inside for u. We're putting that here, and now we have the power series representation of log x in powers of x minus e. We still have to do some algebra on it, but that's the basic picture. All right, so we have log x is equal to 1 plus summation n equals 0 to infinity, negative 1 to the power of n times x minus e divided by e to the power of n plus 1, all divided by n plus 1. Let's simplify this. We get f of x is equal to log x. This is equal to 1 plus summation n equals 0 to infinity. And we can write this part here, x minus e divided by e to the power of n plus 1. We can write this as x minus e to the power of n plus 1 divided by e to the power of n plus 1. And let's not forget negative 1 to the power of n in the front. And all of this is divided by n plus 1. So we now have the power series of the function log x in powers of x minus e. Powers of x minus e. And we were able to do this by applying some algebraic tricks as well as using the hint that was provided. So now we need to find the radius and the interval of convergence. So let's do that. So radius and interval. Interval of convergence. Now let's go back to the hint that was given. Log of 1 plus u, this function has a power series representation, summation n equals 0 to infinity, minus 1 to the power of n, u to the power of n plus 1, divided by n plus 1, and the radius of convergence is r equals 1. This power series converges for the values of u less than 1, larger than negative 1. This is the interval of convergence for this power series. But you might recall that we let u be equal to x minus e divided by e. So that means that the power series for log of 1 plus x minus e divided by e converges for u less than 1, larger than negative 1, or absolute value of u less than 1. But u is equal to x minus e divided by e. That means absolute value of x minus e divided by e is less than 1. If we simplify this, we get absolute value of x minus e is less than e. Simplify further, get rid of the absolute value, we get x minus e is less than e and larger than negative e. Now, if we simplify this, we're going to get the interval convergence for this function as x less than, add e to both sides, we get 2e on the right-hand side, and 0 on the left-hand side. This is the interval of convergence for this function here. X is less than 2e, larger than 0. So this is the interval convergence for the function log x in powers of x minus e. What is the radius of convergence? The radius of convergence, r is equal to e. All right, so now we have the power series representation of log x in powers of x minus e. We also found the radius of convergence. The radius r is equal to e. That's the radius of convergence. The interval of convergence is x less than 2e, larger than 0. And let's expand out this series. We have log x is equal to, plug in n equals 0 inside the summation, and we're going to get x minus e divided by e. Plug n equals 1, and we're going to get minus x minus e squared divided by 2e squared. And plug n equals 2, we're going to get x minus e to the power of 3 divided by 3e cubed. And plug in n equals 3, we're going to get x minus e minus x minus e to the power of 4 divided by 4 times e to the 4. So that's just plugging in different values of n into the general term for this summation, and we expand out the series just to get a feel of what this series looks like when it's expanded. Clearly, we have the power series representation of log x in powers of x minus e. That's the important part. We're not expanding this in powers of x. We're expanding it in powers of x minus e. And the interval of convergence is x between 0 and 2e. That means for this function log x to have this representation, this power series representation, the values of x must be in this interval. All right, let's summarize. So we started by writing log x as log of e plus x minus e, and then we factored out an e, and then we applied the log rule so that we can get a representation, so that we could use the hint that was given. So we get log of e is equal to 1, and here we have log of 1 plus u. And recall we were given this hint, log of 1 plus u. The power series representation for the function log of 1 plus u is summation n equals 0 to infinity, negative 1 to the power of n times u to the power of n plus 1 divided by n plus 1. So after we applied the algebraic tricks, it was actually pretty easy once we applied this hint to find the power series representation of log x in powers of x minus e. All right, thanks.